I welcome you all to the second SLN webinar on climate change in mountain areas series. Today's webinar will focus on the impact of climate change on mountain ungulates. As you all know, and I am very pleased to welcome our speaker, Dr. Sandro Lavari. Ungulates are a diverse group of mammals, as you all know, with about 227 species and are present in every ecosystem of the world. Here are the, and they are the very first type of animals human associated with themselves as mean of food source, as mean for food source, transportation, and for agriculture practices. The increasing human population has overexploited these animals, and in some parts of the world, ungulates were dragged to verge of extinction. Some of these mountains are now facing an ever-threatening issue of climate change. Studies have already showed climate change has impacted many species of mountain ungulates, and as a consequence, also carnivores such as the snow leopard. We are thankful to have Dr. Sandro Lavari join us today and discuss how climate change has impacted ungulates. Dr. Sandro Lavari is researching the behavior, ecology, and conservation of large mammals across the world. His contribution to science include some 240 full papers and 10 books in his 50 years of research career. From 1990 to 2016, he has been full professor of animal behavior at Siena University, Italy. He is now retired, but remains very active in research and is professor emeritus at the Nature History Museum in Grosto, Italy. In 2020, he was elected chair of the steering committee of the Snow Leopard Network. Sandro will speak for approximately 30 minutes. If you have any questions or comments, we encourage you to add it to the comment box. After this talk, we will try and address all the questions and move into a discussion. So please prepare questions and thoughts. Now, I will request Professor Dr. Sandro Lavari to share his insights. Please, sir.
Okay, thank you very much, Hussein, and thank you everybody who are participating. And I'm going to share my screen. Can you see my screen?
No, not visible to me.
No. Oh, okay. It's long last.
Okay.
Sorry, I apologize. So you see the title says that we are going to talk about the transitions between the effects of climate change to carnivores, going through herbivores and before herbivores, pastures, because herbivores have to feed. So any change on grassland composition, on vegetation composition, will reflect some changes in the distribution and the numbers of herbivores who happen to be prey of carnivores. So if plant communities and the herbivores move to other areas or locally disappear, carnivores will have to adapt. The ongoing climate change by now is a fact, and I think that nobody, or at least nobody rational, can deny it. Temperatures started rising already early in the last century, but they had a sharp increase in the 80s, and they are still growing. We don't know for sure 100% what is behind this climate change. It could be greenhouse gases, it could be a natural climate change, or it could be both. And I believe the last issue is probably the right one. At any rate, if there are no changes in the determinants of the present climate change, it has been calculated, just to give an idea of the heavy impact that a climatic change will exert on nature. About 36% of the glaciers will be gone earlier than 100 years in the future, some 80, 100 years. And if the determinants of the climatic change do not stop now, then you can expect, it has been calculated by experts, that about 70% of the glaciers will be gone. So you can, from Hindu Kush to Himalaya, passing through Karakoram. So you can imagine the enormous impact that the absence of glaciers will determine on vegetation and in turn also on animals. This is not the first climatic change which has occurred on Earth. Just remaining in the Pleistocene, there are some 50, a minimum of 50 climatic changes to the warm, and about 50, which means 100 in total, climatic changes to the cold. You can see the oscillations in this map. And the time scale of each of these measured climatic changes has been hundreds rather than just tens of years. And all extant species have survived, otherwise they not to be here presently. But there is a but. Each climatic change will drive some faunal change, some change in the distribution and abundance of wildlife, because a climatic change will have an impact on the different habitats, and it will alter the animal communities. And if you alter an animal community, then you trigger the potential for competition between species, because new species will arrive to areas where they were not before, and because some resources will become scarce, and then there will be some interspecific competition, even remaining between herbivores, for example. Now, on mountains, which are a strongly seasonal habitat, you can expect that the vegetation, well, we know that the vegetation is strongly regulated by rainfall and the temperature, in turn also by snow cover and so on. Vegetation, which depends on temperature and rainfall, means food for herbivores. So high quality vegetation, high quality food resources will require the appropriate rainfall and temperature. And the quality of resources will influence the health of the females during the summer months, the quality and quantity of milk which they will provide to sucklings, and in turn the quantity and quality of the milk will determine the juvenile growth. And if a juvenile is still small when the winter arrives, then the winter survival will be impaired. So you see how this chain of events are related. Seasonality will determine the quality and abundance of the right pasture. The right pasture will determine the health status of females, which will mean better milk and more abundant milk for the sucklings. And in turn, the survival in winter will be higher than in if the vegetation is not appropriate. So, to conclude, pasture deterioration or loss of the appropriate pasture will determine a greater juvenile winter mortality, which in turn will have an impact on the population dynamics of herbivore populations. I'm going to summarize a study which we did on the Apennine chamois, which is a mountain ungulate living in central Italy, in the mountains of central Italy. And it's a vulnerable species according to IUCN, and there are no more than some 2,500 individuals distributed in 4 or 5 different populations. Okay, this is the distribution range in the 20th century. Now you'll see what has happened in the 21st century. So in the 20th century, they were confined to a small area of the Abruzzo, Latium, and the Molise National Park. The altitudes, the elevation is not so great in the Apennines. It's about 1700s up to 2000s. So we are not in the Himalaya. But this is important because you can expect that the effects which of the climate change, which are now active on low mountains, will climb up to high mountains as well on time if there are no change in the determinants of the climatic change. So last century, the Apennine chamois was confined to the what we could call the historic core range, made by 2 areas, one the area of the Mount Amaro, the other of the Val di Rose area. Both of them are relatively low, as I said before, and there were plenty of chamois. You can see that they were, curiously enough, in one of these areas, they were more than 3 times what they are now. And in the other area, they were twice as many, more than twice as many as they are now in 1976. But in 2014, we counted them again, and we found a completely different picture, because the decrease in these mountains had gone together with a sharp increase in closer mountains where they did not occur formerly. So in 1976, in practice, there were no chamois in these other 2 mountains, which are higher of the historic core range. So a decrease of about 50% in the historical core range at lower elevations, but a shift to other mountains with greater elevation, which we have considered as refuge areas. And we worked on this species for about 10 years, and a group of people, zoologists, botanists, and the statisticians on whom we relied for the model which we had to use at the end of this study. And of course, myself, I am included in the others, worked on it. And when we compare the plant community changes between 1976 and 2014, then we find a great change in the composition of the pasture. Originally, this unpalatable graminoid grassland was confined to this small part of the chamois range. Now it has expanded to cover about half of the chamois range. At the same time, the forbs, especially a plant association based on clover, has decreased a lot, because formerly the red color, that is forbs, were covering most of this black area now used by unpalatable grassland. And there has been a decrease of about 40%. This is very bad, because a study conducted when the climatic change was not yet known, showed that this plant association is particularly important for females and juveniles, to feed the females when they have to lactate the young, and for the juveniles to wean. Weaning is an especially important part of the growth of any young animal. If you suffer because of lack of food during the weaning, your body, your skeleton, your bones will not develop properly. So this is a very important plant association for the survival of this mountain ungulate. In fact, the effects of the disappearance of forbs from the our study area, which we compared to a refuge area, to one of the two refuge areas with an elevation of more than 2,000 meters, has shown that the feeding frequency and the diet quality of females was less, significantly less, in the areas where, by the way, together with the climatic change, the red deer came over. So actually, in our initial part of the study, we expected that the red deer was the main culprit of the decrease of chamois. And our first experimental approach was to test the importance of red deer. We were not really yet conscious that the chamois might have grown their numbers in neighbor mountains. So we started by looking at the presence of the red deer as a covariate, so to speak. And by looking at the effects of red deer, we found that red deer had a great effect, because the feeding, the pattern of lactation, the social stress of females, and the population dynamics of the two areas with red deer were significantly worse than where only chamois were present. We decided the red deer was involved because the numbers of red deer had increased enormously between the decade between 1975 and 1985. In 2010, you can see the growth of the deer population in the chamois, in the formerly chamois pasture lands. There was, we could show a great ecological overlap between red deer and the chamois. A 90% overlap in feeding habits, a 75% overlap in spatial distribution, and through trampling and overgrazing, the percentage of bare ground in the areas with red deer had a sharp increase during the summer months. In the area where only chamois were present, the impact was not so important. So we concluded that the red deer was competing with the chamois because of some reason. And we thought that since the population of red deer was growing, the population of chamois was decreasing, they had, let's say, more or less the same food habits and lived more or less in the same areas, then we thought that it was a classic example of competition between two species, by a competition by resource exploitation. The number of bites given in a minute by chamois to the pasture was not, was depending very much on the temperature of the preceding days, of 15 days before. You see, in the area with red deer and in the area without red deer, still the temperature had a heavy importance on the use which the chamois were giving to the grassland. And also the rainfall in the preceding days had an effect on pasture quality. You see that again, as the rainfall increased in the preceding days, then the number of bites per minute given by the chamois increased in both areas. We concluded that independently from deer presence, temperature and not so much rainfall, because it was not so significant, had indirect effects on the grazing activity of chamois. So we wondered, what is the interaction between temperature and vegetation on the feeding rate? And we compared the feeding rate on forbs, clover, and graminoids. And the number of bites per minute was strongly influenced by the temperature of the preceding days. As I said, not so much from rainfall, but temperature was important. And it had a negative effect on forbs, but a minor effect on graminoids. So the effect was stronger on the pasture, especially important to female chamois and kids. Also, the number of displacements during feeding between female chamois grew together with temperature in the preceding days, and the number of the percentage of direct aggression decreased with rainfall. We concluded that independently from deer presence, temperature was important in determining some effect on the feeding of chamois, also on the feeding behavior, and also to a lesser extent rainfall. And there was the indirect effect of a greater intraspecific aggression between members of the same group. The effects on the juvenile winter survival was strongly dependent on drought conditions, because we conducted this study between 2011 and 2013. And in the summer of 2012, there was a drought, which means that the following year, we realized that a lot of kids were missing. There were a few yearlings in comparison with the number of kids. So mortality of kids must have been greater, significantly greater in 2012 than in the year before and in the summer of the following year. And that was the same in areas with deer and without red deer. You see, this is the refuge area, and this is the area in the core range, which had been colonized by red deer. The deterioration of pasture was different between the cryophilic nutritious plants, that is, plants like forbs growing on a terrain with long duration of snow, whereas on plants which were not cryophilic, or at least not so much, the effect was less. There was a minor feeding rate of females, a greater competition of females to access the best food resources, and we could document a greater mortality of juveniles in the following winters because of the lack of these special forms. Now, by convention, we call a climatic change as such, according to the World Meteorological Organization, if the climatic change lasts more or at least 30 years. So by now we are in a technically correct climatic change, so to speak. And it has been documented all over the world that there have been continent-wide responses of mountain vegetation to the climatic change by shifting to a higher elevation. This has been documented mainly in European and the North American mountains, but there is information also for the Himalayas. When we looked at the variation in temperature in the years between the 70s and the last decade, we found what we did not expect, that the timing of summer, autumn, and winter temperatures were not significantly changed. But there was a great change in the spring green up and the temperature in, well, not only spring, also a little bit in early summer, between spring and summer. And in this season, there has been an increase of about 2 degrees centigrade in our study area, which is an enormous amount. According to the EVI, which is a way to estimate the green up by using information from satellites, the EVI means Enhanced Vegetation Index, and is similar to the more popular NDVI, the Normalized Difference Vegetation Index. and can be used to quantify vegetation greenness, especially because EVI corrects for some atmospheric conditions and the canopy background noise. So that's the reason why we want to use the EVI instead of NDVI. Anyway, the result was that in the previous core range, below 2000 meters, there was an anticipation of 25 days, almost a month, of the green up, which did not, could not be found higher up in the refuge areas above 2000 meters. So, as you might expect, the climatic change was recognizable. The effects of the climatic change at the vegetation level were much more detectable at lower elevation than higher up at higher elevation. Then we had to use a model to estimate on time the increase in mean spring temperature observed between the 70s and the last decade, and simulating the increase if no difference will occur. We don't know. Maybe we are being pessimistic, but I don't think so, because as we said, climatic changes, once they have started, tend to last maybe hundreds of years, in some cases thousands of years. We had only few information scattered between the 70s and the last decade about Forbes cover and counts of chamois. So we had to model according to 4 potential scenarios. In one, we assumed that the increase in mean spring temperature would have led to this pattern of decrease, or this pattern of decrease, or this pattern, or these patterns. All these patterns would be theoretically possible, and we wanted to see the differences between these scenarios, theoretical scenarios. And the percentage of forbs in the grassland cover followed this pattern projected in the future. The juvenile survival, winter survival, again modeled through the 30 years before, between the 70s and the last 10 years, projected the evolution of the populations to different levels of decrease, with the most optimistic one showing an 80% mortality of the kids, of the juveniles, and the worst scenario, the pessimistic one, 95% mortality. So it's a near extinction, local extinction. To summarize, we cannot deny a pasture depletion in terms of quality and quantity in the former chamois range. Now we know that there is an ultimate cause, which is the climatic change, which have uplifted the plant communities from lower elevations to higher elevations, where higher elevations are available, because the mountains which didn't have a higher elevation, well, were abandoned by chamois. I mean, they died. They just, they did not move. They colonized, but the females who were living on the lower mountains, which were suitable habitat up to some tens of years ago, several tens of years ago, and now I mean, they had nothing to eat, so they were feeding in the area because being grown up, they could still feed, but then they died, and they were not replaced by younger females because the younger females died when they were kids. But approximate cause is also the presence of a competing species such as the red deer, because by trampling and overgrazing, we could show that they contributed to the depletion of the pasture. So they accelerated, they acted as catalysts of the disappearance of the pasture, the good pasture for female chamois during the summer. And this led to an increased juvenile winter mortality, especially in which led to this picture with the near extinction in two areas, in the former areas, 1976, and the decolonization of refuge areas at higher altitudes, not on the same mountains, because these areas were of lower elevation. This mismatch between the green up and the weaning of ungulate kids has been found also in other study areas by now. And again, we have the pattern that to an earlier green up, that is in the birth season, spring, there is not an early brown down. That is, the autumn temperature doesn't seem to influence very much not to be influenced very much by the change in temperature. So the females get into estrus at the usual time, the same time they were getting into estrus in the last century. Kids, juveniles, are they are fertilized at the right time, but they are being born mismatched with the green up. So when they, well, apart from the fact that the milk quantity and quality, as it has been shown in some of these studies, will be affected, but especially the growth, the body growth of kids will be affected, and then they, in most cases, will not be able to overwinter. And this has been shown for the alpine ibex in one population of alpine ibex in Gran Paradiso National Park. For mountain goats, although it was shown a decrease in body mass of juveniles, but not an increase of population decline. In the case of ibex, initially, the decrease of snow depth because of climatic change actually had a positive effect on winter mortality, because initially the snow depth, the decrease of snow depth made appropriate resources available earlier than usual, so the females could feed even better than usual, and the population size increased quickly. But later on, just several years later, the population decline started, and from the 90s onwards, there has been a decrease of 50% of alpine ibex in Gran Paradiso National Park. So as I said, mountain goats were shown to have a decrease of body mass of juveniles in relation to this mismatch, and also bighorns in two populations, it was shown that the mismatch had an impact on body growth of juveniles. And in one study, the mismatch also led up to an increased juvenile winter mortality, very much like in our study area where we looked at chamois. And now we come to carnivores. What about carnivores? Well, they have only one option. They will have to follow herbivores. And let's not forget the forest uplift, which is another effect of the climatic change. So if carnivores will follow herbivores, then some trouble might arise. We have some data from the Sagarmatha National Park, where we worked some 10 years ago, and we looked at the diet overlap of the snow leopard and the common leopard. And they had a pretty high diet overlap there, some 70% of overlap, greater in winter than in summer, but still sizable also in summer. So this is the clear potential for competition. When the two species tend to feed on the same food resources, you don't have competition if the food resources are abundant. But when there is a decrease, when the resource becomes scarce, then one of the two is bound to keep growing their numbers or remain stable, and the other is going to be outcompeted. In this case, we can expect that the bigger and more adaptable common leopard will take over and will replace the habitat of snow leopards. We have something like that documented between red foxes and Arctic foxes. There have been a number of studies, and several of them have shown that the red fox is colonizing, conquering would be probably the right term, the terrain which formerly was used by the Arctic fox. The Arctic fox is less competitive than the red fox. Red fox is bigger and more adaptable, more flexible. Exactly like the common leopard and the snow leopard. So the uplifting of the forest tree line will erode, will decrease by 30 to 50% the habitat suitable for snow leopards in the Himalayan range, as a model published by Forrest and co-authors suggested. And with the uplift of the forest, the common leopard, the tiger, and the wolf will follow. The snow leopard will probably have to move to refuge areas which have been identified in a study published some years ago. But please notice that this means a decrease of about 50% in respect to the present snow leopard range. So it's a strong decrease of range. What about mountain ungulates? Well, mountain ungulates are about 45 species, depending on whether you determine their taxonomy by splitting or by lumping them together. But let's say that they go between 30 to up to 45 species, different species. And the IUCN, which is following this number, 45 species, suggests that less than 75% of these species are in the red list, are threatened. And they live in subarid mountains, or by the way, you can see two Arabian tar here in this picture, but they are difficult to detect because they can melt so nicely on the background that it's difficult to see them. Anyway, as you can see, this is a very arid area, not comparable to what you find in Tibet or Alaska or in Southeast Asia. So these 45 species live in a variety of different habitats, which presumably will be affected by the climatic change in different ways. So we should not throw out the baby with the bathwater, because mountain ranges differ in elevation, in aspect, latitude, and even shape. You know, if you have a shape like this, you can expect some variation in vegetation different from what you could expect on a plateau like this one. Or if you have a chain, again, you have a different kind of mountains. So you can expect a great variability of pattern phenology of the effects of the climatic change on herbivores, which is a challenge to any modelist. And I stress that many more long-term field studies are necessary before coming to conclusions. There will be definitely changes and shifts in the vegetation, and the herbivores will follow the shifts in vegetation, and they will be followed by carnivores. But the refuge areas may be anywhere. But of course, if refuge areas are not accessible as they were in the previous climatic changes during the Pleistocene or even during the Middle Age, because humans have taken over the connecting terrain between a former area and a refuge area, then wildlife may be in trouble to migrate to an appropriate aspect or to a higher elevation. To summarize, we start from climatic changes, which change vegetation. You have the vegetation changes and the vegetation shifts. According to them, you can expect the changes in the distribution of herbivores and their numbers. And if herbivores move to other areas or disappear from one area, then you'll have definitely effects on the distribution and the numbers of carnivores. So all species, distribution and abundance, are and will be affected by the climatic change, with some additional trouble if there will be other species arriving to the refuge areas, and the competition between these not co-evolved taxa will occur. So the final key message is that climatic changes trigger plant animal population changes, especially on mountains, with a cascading effect. Change phenology will depend on local habitat features, like, for example, geomorphology. Moving to refuge areas will prevent global extinctions, will not prevent local extinctions, but will prevent global extinctions. And heavy human alteration of habitat features may prevent moving to the refuge areas, thus favoring perhaps global extinctions. I like to emphasize that long-term data collection in the field, not in the lab, is necessary, still necessary to understand, predict, and cope with the effects of the ongoing climatic change. Charles Darwin, in The Origin of Species, has a line which tells that climate plays an important part in determining the average numbers of a species. So he recognized that climatic changes, which he knew, can play an important effect on the amount, on the quantity of the individuals of a species. And he remarked that periodical seasons of extreme cold or droughts, he believed to be the most effective of all factors influencing survival of animal populations. So once more, Charles Darwin had somewhat predicted ahead of us by 150 years what some people think they have just discovered. That's all. I have added my email address. This is my email address, not Charles Darwin. And if you want the PDFs of our papers, or you want to ask questions after this meeting, please go ahead and write email messages to me. I think that's all. Yes. Thank you very much.
Thank you, Lawari, for Orion has asked, could mortality be higher in summer?
Could drought lead to females not producing enough milk?
So he asked, could mortality be higher in summer too? And could drought lead to females not producing enough milk and kids die in the summer too, but they are too small to detect yet?
Yeah, that's definitely one thing which, what should I say, haunted us. We wanted to look at it, but it's extremely difficult because mountain ungulates have the bad habit to go, especially if predators are present, to go to very difficult terrain to give birth. So neonatal mortality is difficult to see and to document. In practice, you can count the kids when they are about 1 month old, or maybe a little bit earlier. But again, the birth season is somewhat diluted in about from 2 to 4 weeks. So it's not easy to detect neonatal mortality. And when they are already juveniles and living in the meadows, again, it's difficult to find their carcasses because a kid can be preyed by eagles, wolves, bears. I mean, it's really hard to be sure that you can assess their death. And the catching kids is also difficult because of a number of reasons. We tried many times with different systems, but we always failed. You can catch kids only when they are several months old. You can't shoot a syringe because the target is too small, so you risk to kill the juvenile. They will not be the first to enter a net trap. The adults will go there first. So again, it's difficult to catch the young, and they will react very quickly to any potential danger. So it's really difficult to catch them. We failed, we tried, but we have tried in two different study areas, and other people have tried in one more study area, as far as I know, speaking of chamois, between the southern chamois and northern chamois, both species. And we always failed. So I expect that there could be an effect, yes, but we can't tell. Sorry.
So Pion is asking that milk production of cows drop a lot in hot summer. Do those herbivores show this similar phenomenon and the babies die in summer?
I have another question. I think I have your question, Hussein.
Yeah.
Yeah, which tells which ungulate species are more vulnerable to climate change. For example, ungulates with larger ranges or ungulates with short ranges. Well, I mean, you should speak in terms of populations. I would say that populations which tend to live in narrow ranges are probably in a much greater danger, because ungulates with larger ranges maybe will decrease in numbers, but some of them might still escape. But if they have short distribution, I mean small distribution ranges, narrow ranges, they risk more. Have I got your question right?
Yeah.
That's what you asked. Okay.
Yeah.
Then there is another question. Sandro, you mentioned that some ungulate species habitat could be pushed to higher altitudes. What do we expect in areas such as the South Gobi, Mongolia, where ungulates occur at the highest elevations already, as the good question, as the mountains only range up to 2,500 meters or so? That's a good question. I would expect that maybe being at a higher latitude, you'll probably receive an impact of the climatic change later than down south. So I would expect the effects of climate change to be greater in the Himalayas, for example, or Hindu Kush, than to Mongolia. But when you get them, they may be even worse, because ungulates, well, they may have some aspect which will remain suitable, and they may migrate to that part of the mountains. But I would expect a greater effect, because they don't have a higher elevations. So have a good luck. Not so much for the time being, but for the future.
So we have another question from Orion.
Yeah. Are the ibex in Gran Paradiso competing with any other species? Have any new competing species emerged in the ibex habitat? Another good question. Well, I'll give you my, well, I don't want to say opinion, let's say my hunch. And then I give you the official information. The chamois have grown up their numbers together with the decrease of ibex. So my hunch is that in Gran Paradiso, you have a comparable, if not the same, a comparable, you could have a comparable effect of the chamois acting against the ibex, So the ibex usually stay at higher elevations than chamois. But since the mountains in Gran Paradiso are over 3,000 meters, well over 3,000 meters, then there is elevation where to migrate. And And the chamois are also less specialized than ibex. It has not been really studied properly, but there are some hints about that. So initially, the ibex grew their numbers together with the chamois, but then after several years, the chamois kept growing their numbers and the ibex started decreasing. And my hunch, and I say it's my opinion, so, and it is an opinion with no data to support it, is that they may have exactly the same picture as we had in Grand Paradis, in our study area, with red deer and Apennine chamois. Actually, the official explanation given the publication which was published about this is that well, they don't really know, that they suspect that the young of chamois in the Alpine range are born about 1 month earlier than ibex. So the lack of appropriate food, the appropriate green up food will be worse for the growth of ibex kids than chamois kids, which might also be, I mean, I don't know, but I think they should consider also the overlap in food habits and maybe some other parameter. And in ecology, you know very well that hardly ever you have only one reason behind some effect, some issue. Usually there are more than one acting together. One may be greater in respect to the others, but hardly ever is just one. So we need to study this. There is a great necessity to go again to the field and collect data. Stop using only computers. This is my how should I say, my exhortation, so to speak.
So again, Orion has a question.
Yeah.
So he's asking.
In the case of Arctic versus red foxes, there is likely an effect of the fact that the Fennoscandian population were substantially weakened before the red foxes started.
Sandro, Orion's here. Let's ask him. Orion, if
Yeah.
it's okay.
Oh, it's from Orion. Yeah, okay.
Yeah, Orion, please go ahead.
Please, Orion.
Yeah, the Arctic foxes wasn't so much of a question, but I did ask him about how do you think that the snow leopards will be affected by climate change as the tree lines shift to higher elevation? I mean, that could help the tigers and leopards and so on, but do you think these steep areas could still act as a refuge for the snow leopards?
I mean, I think that if there were no competitors in the forest, I suspect that the snow leopards could adapt, perhaps to living in forest as well. But the problem is that the forest will bring along powerful competitors for snow leopards, at least locally. The tiger has been documented in Bhutan, for example, in a snow leopard elevation. The common leopard has been documented in several areas, although data on food habits have not been produced beside our work in Sagarmatha. But I don't see why a snow leopard, a common leopard should disregard the prey of snow leopards. I mean, they probably can prey on the same animals, I mean, as much as in Sagarmatha. So I would expect that. And then, of course, you have an animal which adapted to live in a very special climate, like the high altitude in the Himalayas, Hindu Kush, Karakoram, and also at a comparable climate in Mongolia at a higher latitude. The altitude, as we said before, is less, but the latitude is more. So the overall habitat situation is not so different. I think snow leopards will be in trouble. It will depend on the duration of the climatic change. You know, if the climatic change reverts to a colder change within maybe 100 years, probably snow leopards will still be able to recolonize lost terrain. But if it goes on, it might be in serious trouble, because it's a very, I mean, you know better than I know, it's a specialized animal. And in a review which we made several years ago, well, actually just 1.5 years ago, looking at the food habits of different species of large carnivores, it was found that the snow leopard is a special case. It's the only one which doesn't grow its food niche together with the increase of local prey. So if an area is rich in prey, you can expect the tiger, the common leopard, the wolf, I mean, all large carnivores, including the spotted hyena, the lion, and so on, they will increase their food list, so to speak. They will follow the prey richness. The snow leopard will still prey on just 1-2 main prey. So it seems he is also a specialized, rather specialized large predator, which may put him in trouble.
Yeah. So we have final question from Noras, and he's, I think, suggesting for a change in IUCN red list of snow leopard, because he believes that climate is highly impacting the snow leopard.
Sorry, who is asking that?
Yeah,
Oh,
that last question,
okay.
Noras.
Yes, I found it. Thank you very much. Yes, I'm sorry. I totally agree with great enthusiasm. I think that the IUCN red list status has been a very rushy move, because it has not considered anything else but numbers given by the IUCN. Now, you can't talk in terms of numbers alone. You have to consider many different parameters. Who cares whether snow leopards are more or less of 2,500s? 2,500s is a number which has been created by someone. It's a rule of thumb. But when you have a specialized high elevation cold adapted species, and you have a climatic change going on, then you have to change parameters. You can't keep the same parameter of the same you use for the common leopard or even for the tiger. I mean, it's something different. I think that the IUCN criteria should be modified greatly and not pretend to be so mathematical. The variation in wildlife is so great that you can't find a criterion which will be useful for all different wildlife species. So I think that the red list status of snow leopards should be thought over again. Thank you for asking me this question.
Yeah, finally, Justin is asking to consider climate change in the ICN assessment.
I think there is another question before from Kamal Tapa. Oh no, it's directed only to me. Okay, so I go on. Yes, is climate change considered? Not that I know. I mean, they started considering it. I remember several years ago, maybe 3 years ago, there was some document where they were starting considering it. But I don't think there has been any change in the criteria IUCN is using even now to assess the status of the different species. Hopefully there will be in the future.
Okay, so thank you, Dr. Lavari, once again for your time and valuable discussion. And I also thank all the participants for participating in the webinar. Thank you very much.
Well, thank all of you for your patience and for listening all the time up to now.